Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel. This video is part 2 of graph of sine functions. So in part 1, we talked about what the graph of y equals sine x looks like, and we put in different values of a just to see how it changed the graph. So we talked about the idea of amplitude. We also talked about the idea of period. And I want to define what period will be for any function when we have coefficients of x that aren't 1. So the period, whenever we have a 1 there, the period was always 2 pi, but the period will be 2 pi over b when b changes. So what I typically do when I'm graphing these is I know the length for the graph to complete one cycle, and there are 4 increments in that one cycle. So if I find the period, I then find the increments by taking the period and dividing by 4. And I'm going to show you with an example how that's going to be really useful. So in this particular example here, if I wanted to find the period, I know that it's going to be 2 pi divided by b is 2, the way I've defined b. So the period is going to be pi units. That means the increments, those 4 increments, are going to be pi divided by 4. And that's going to make it very, very easy to draw my graph without having to find a lot of points for the graph in one cycle. So my graph starts at the point 0, 0 for the sine function. And if I put a 0 in, 2 times 0 is still 0. Sine of 0 we know is 0. My 5 key points change now because the period has changed to pi instead of 2 pi. So that means it's going to only take pi units to complete one cycle. And I know that because a is 1, my graph is going to look like this. And I need to find the 5 key points. I've got 2 of them, but I need to find these 3. And that's where my increments come in. If I start at 0 and I have an increment of pi over 4, this will be pi over 4 units. So my key x values will be 0, pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, and 4 pi over 4, which reduces to pi. That's all I needed to do, was find what the period was, find the increments, and then do my points from 0 using the increments to let me know. I know that my y values will be 1 and -1 because a is 1. So the amplitude of this is 1. I also drew y equals sine of x. It's the dotted graph, just so you could see how y equals sine of 2x compares to y equals sine of x. Hopefully you can see that what happened was the function completed its cycle in less time, in half the time, so it actually shrunk horizontally. And we could complete more cycles, twice as many cycles as we could with this function. Let's do another example. My next example is y equals 3 times the sine of 4x. So I know right away my amplitude is 3. That's going to be the highest value that the y value reaches, and -3 will be the lowest value. Then I would find the period. B is 4 in this case, so period would be 2 pi divided by 4, which is pi over 2. And then to find the increments, the distance between each of those significant or key points, I would divide that by 4. So pi over 2 divided by 4 will equal pi over 8. My sine function still starts here. It's still that same basic shape, but now I'm going to a value of 3 on the y-axis and -3. And my increments on my x-axis are pi over 8. So this will be pi over 8. Add another pi over 8 will be 2 pi over 8, which is pi over 4. Then 3 pi over 8. And then 4 pi over 8. 4 pi over 8 would be pi over 2. So there's my zeros. And then I go up to 3 and down to -3. That gives you an idea of what that graph looks like. So once I've got my amplitude, the period, increments, and I know I'm starting at the point 0, 0, and I know what the shape of the sine graph is, it's fairly straightforward after that. When you do more examples, this will become easier. In the example, y equals sine of 1/2 times x, my coefficient for the sine function is 1, so the amplitude is 1. The period will be 2 pi divided by 1/2, which is like 2 pi times 2. Remember, when you divide, just a quick review of fractions, you multiply by the reciprocal. So the period, the length of time along the x-axis it takes for this graph to complete one cycle will be 4 pi now. So when I'm looking for the increments, I always divide by 4 because there's 4 increments with those 5 points. The equally spaced distance will be pi. So my graph starts here and goes to a value of 1, value of -1. My points are going to be 0, pi, add another pi gives me 2 pi, add pi again is 3 pi, and 4 pi. So those are my 5 key points. This is what my graph would look like. So this coefficient actually stretched the sine function horizontally. And I find that's going to be the easiest way to draw these. Find your amplitude, find the period, figure out what the increments are, and then take your shape and you'll know what those one cycle of the graph key points will be. Okay, in this example we have a coefficient of -1, which remember flips the graph over the x-axis. We'll try that. And b is 3x. So the amplitude, remember, is the absolute value of a. So the amplitude is 1. The period will be 2 pi divided by 3. 2 pi divided by b, and b is 3. The increments are going to be that period divided by 4. Two will cancel there, so I'm going to get pi over 6 as the increments. So my points along my x-axis will be 0, and then I add pi over 6 to that. Add pi over 6 to that, and gives me 2 pi over 6, which is pi over 3. 3 pi over 6, which would be pi over 2. And 4 pi over 6, which will be reduced to 2 pi over 3. You can write them as pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 if you wish, but I typically reduce fractions. Now, instead of the sine function going up, because of this negative, we flip it, so it goes down to -1 first. So the graph will look like this. And that's one cycle of this graph. Some of these questions that you will run into will have pi as a coefficient for your x. So it's the same process. Our amplitude is still, in this case, 1. The period is 2 pi divided by b. b in this case is pi. So the period is 2 units. And the increments will be 2 divided by 4, which would be 1/2. So my x values starting at 0 will increase by increments of 1/2. So 1/2, 1, 3/2, and 2, because it takes 2 units to complete a complete cycle. So my graph is going to take a look like that. So you could see pi there or just regular numbers. In part 3, we're going to take a look at one more transformation on the sine graph, but practice these first. Take care.